So good morning, everyone. Happy World Intellectual Property Day. Thank you for choosing to spend your time with us this morning as we celebrate innovation and invention. We're going to start out with a brief explanation of who we are and go over our purpose today and our agenda, and then I'll introduce very briefly our guests, and I'll do a little bit more thorough introduction as we get to each one. So I will ask you, if you're not speaking, to keep your mics muted. If you have any questions as we're going through this, or you want to comment on something that our speakers are talking about, feel free to put something in the chat and we will get back to that. So my name is Kim Mozingo, and I'm a program manager with the Maryland Defense Technology Commercialization Center. Joining me today is Dr. Gary Evans and Griffin St. Louis. Gary is the director of the program, and Griffin is also a program manager. And Gary will be speaking later on this morning, a little background on DefTech. So just very briefly, we are funded by the Federal Economic Development Administration through the Maryland Department of Commerce to support businesses in helping them connect with the resources at the federal labs. So in this morning, we've got a couple people from the federal lab, so you're going to learn about why do we want to do that and why is that important for business. We're also going to look at a couple of their inventions or their patents that they have available for license. And as I said, if you have questions, just feel free to use the chat, and someone will be monitoring that and let us know when you want to ask a question or a comment. So today, as World IP Day was actually on Sunday, I didn't know it was a thing. We learned about it a few weeks ago and thought we've got to celebrate this because this is what we're all about: invention and innovation, and getting technology into the hands of businesses to help them grow. So any kind of celebration of World IP Day, of course, requires that we hear from inventors and learn about some of the cutting edge intellectual property that's being developed by our Department of Defense labs. And that's available for you to license and develop into a unique product that solves a real world problem. So we have 5 speakers this morning. We're going to start with Mike Steele, who has invented something cool and developed a product that sells globally. We're going to talk to Somnath Sengupta, who has licensed intellectual property from a lab, and you'll hear his story. And we're going to speak with Barry Datloff from the Medical Research and Development Command, and Matt Jones from the Army's Chemical Biological Center. And Gary Evans will talk about how we can help you access this technology. So we're going to start this morning with Mike Steele. So Mike by day is an engineer who's managing a team that supports the Navy. That's what he does during the day. And he's a motorcycle enthusiast the rest of the time. I'm sure he's got other interests as well. I enjoy working with Mike. I've known Mike for a number of years. He is really the complete package. I have watched him grow his business, and it's been absolutely exciting to see everything he does. You can tell he loves the work he's doing with his product. So Mike, are you ready to talk to us and tell us about the problem that you encountered with your motorcycle and how you solved that problem?
Yeah, sure.
Okay.
Let me go ahead and pop some slides up here real quick.
Sure.
Can you see that screen?
Yep, sure can. Thank you.
Okay. So like Kim said, my name is Mike Steele. I live in La Plata, Maryland. I'm a mechanical engineer by degree, but I've worked with the Navy for probably over 35 years. And I'm kind of, like Kim said, I'm kind of the prototypical garage inventor. So about 8 years ago, I developed my first product, which is an automatic chain oiler for motorcycles. And that's what I'm mostly going to talk about today, how this product came to be and the IP journey that I took. And I'm going to try to explain what I was thinking at the time that I did each thing. So I really kind of started this process as an IP novice. I kind of knew what patents were, but I didn't really know much about how to get one. But I was able to work my way through the process and come out with several patents on the other side. And I guess I'm probably still an IP novice. So this product is actually sold in over 40 countries. And I'll tell you, it's really kind of addictive the first time you sell a product that was your idea to somebody that's on the other side of the world. So I've since developed some other products down below the line. Those products have no patents, but we're kind of able to be first to market, which kind of gave us an advantage of getting a lot of the products sold before the competition kind of figured out what was going on. On those products, we've had a couple of copycats, but one thing about competition does when you do get those copycats is it kind of drives you to improve the products, improve your branding through trademarking, packaging, and we've actually contemplating a patent on one of those devices. We're kind of in the search phase now. So the point of this slide really is that you can bring products to market. You don't necessarily have to have a patent, and really there's pros and cons to each way. So I'm going to tell you a little bit about the product, the Motor Breeze chain oilers. It's and kind of why I felt like I needed a patent on this. So this product it's a wind-powered motorcycle chain oiler, which kind of sounds, you might expect to see a big wind turbine on the front of a motorcycle, but it's actually a whole lot simpler than that. So if you see that center picture, that device is really only about 3.5 inches tall. And so what happens, it gets pressurized by wind pressure. If you see in the upper right-hand picture, there's a tube that attaches, that's the side of a headlight of a motorcycle. It attaches to somewhere on the front of the motorcycle where it can catch the air, and that air is ported back into that vessel that you see in the center picture, and that causes that plastic bowl to pressurize. Once that's pressurized, it pushes oil out through a flow restrictor and then out through another tube and down to the chain. And the chain actually rides on top of a little felt pad that the oil is ported into. And if you see the lower right picture, that's actually the felt pad part installed on the motorcycle. So the point of showing you this picture and what the product is that it's a very simple product, which means it's probably fairly easy it would be fairly easy to knock off. I felt like it was a new idea. I had never seen anything like it on the market. There were other products on the market that kind of did the same thing, but they were a lot more complex, a lot more expensive. So I felt like if I was going to make this into a business, I really needed to use a patent to get a head start. So then the next question became, where do I want to try to get a patent? Because, patents are expensive. You can't really patent everywhere. So I kind of took the tact of looking to see where are most of the chain-driven motorcycles in the world. And it turned out that Europe has the most motorcycles. They're more of a kind of a primary mode of transportation in Europe. And then a lot more of the motorcycles in Europe have chain drives. If you see a lot of Harley Davidsons and cruiser type motorcycles in the U.S., those don't have chains. They have rubber belts that drive. So this product wouldn't really be any advantage on those. So the ones with the green check marks there, Europe, the United States, Australia, and Canada, was kind of where we decided to go ahead and try to get a patent. Japan has a couple of major motorcycle manufacturers, but really at the time I was kind of worried about the language barrier, about trying to get patents and not knowing the language. So I kind of ruled out Japan. You could think China, because China has a lot of manufacturing, but really my tact was more to go for the places where the motorcycles are versus where the manufacturers are. But going to Europe, there are a lot of motorcycle manufacturers in Europe. Mostly like Italy, UK. There's some motorcycle manufacturers. So anyway, that's the route I decided to go. This was kind of a wish list of where I would want to get patents if I could, not knowing really how much it was going to cost and things like that. So this is what ended up happening, and this is kind of the timeline of how I got the patents. So of course I first filed in the U.S. I filed a non-provisional patent in the U.S. and that was in December of 2012. And it took about 2.5 years to get that patent. It was probably exactly 2 years from when I filed the patent until I got the first office action. And then the patent was actually issued in March of 2015. So, as most of you probably know, there's really no such thing as an international patent. There's nothing where you can just go file one place and get a patent everywhere in the world. But there is a way that you eventually have to file in every patent office of every country that you want to get a patent in. So, but there is a method that you can kind of delay the process to, give yourself more time to figure out where you want to file, and that's called the Patent Cooperation Treaty. And it's about 150 countries that have signed this treaty that have signed up to this process. So what it allows you to do is delay up to 31 months filing in other countries, 31 months from when your original filing date was. So the way you get into that process is you file a PCT application with the World International Patent Organization, and then you can tell them what patent office in the world you would like to examine your patent. And since my big target was Europe, I said, well, I want the European Patent Office to examine the patent. So what you get out of that process is you get what's called an international search report and opinion on patentability. So they do kind of a worldwide search of, to see if your idea has been anywhere, and they kind of give you an opinion on whether your product, the criteria is it has to be new, have an inventive step, and have industrial applicability, which means that it's something useful. So I got a positive opinion on that. They said there was a few problems with the application, some procedural problems, or but that was a good sign. So 30 months from my original filing date, so that would have been about June of 2015. I applied in the Canadian Patent Office, and that one took I guess almost 3 years. And that patent was issued in April of 2018. Then a month after that, I had to file in Europe and Australia. And Europe's a regional patent office, so you when you file in Europe, you're covering like 50 some countries, and then once that patent gets issued, then you have to decide, or gets granted, you have to decide what countries in Europe you want to file in. But once the European Patent Office approves the patent, every other patent office in Europe will accept the patent. They don't have to re-examine it. So it's kind of a one-time examination. So the Australian patent ended up getting issued in March of 2017. The European patent was issued in December of 2018. That was the last one. So it's about 6 years from the initial filing to the last patent issue. But some of that delay was actually intentional, because I wanted to kind of see where the product was selling, things like that, before I filed. So, some big decision points, like when I went to file the PCT application, that one's expensive. I mean, the US patent, it cost me, I think, $480 to file. And the international, the PCT application was about $4,100 to file that application. And then Europe's expensive too. Then the one thing about Europe, I haven't talked about this much so far, but I actually did all the patent work myself, except in Europe, you can't practice before the patent office unless you're an attorney. So you have to have an attorney to handle all the correspondence with the European Patent Office. So I had to get some help there. But Europe's expensive, but it also covers a lot of countries too. So I talked about kind of writing the patent myself. I was just going to give you an idea of how that all came about and how I made that decision. So, like I said, I was a novice getting into this. I didn't really know much. So first place I went was the U.S. Patent Office website. They talked about scams. Be careful about like invention companies that they're probably going to take a lot of your money and you won't get too far. They talk about should you use an attorney. They pretty much recommend that you do. So I took that advice, and they even they've got a link to where you can find a list of attorneys. I called an attorney, and to make a long story short, he said, you really need to think about your business plan where you can stand to spend about $20,000 over the next few years. And at the time, I had my kids were a couple of years away from going to college, and I said, if I go that route and get $20,000 for a U.S. patent, I really wouldn't have any money left to go any further internationally or to actually get the product on the market. So the next step is I went and started educating myself on things like how to do a patent search, actually use some of the patent office tools to do a search. Once I kind of satisfied myself that there was, that I thought I would have a good patent, I started drafting it, and I used a book called Patent It Yourself. You can find it on Amazon for about $30. And I used Google SketchUp, which is a free program to do the patent drawings and stuff. And it's really worth reading this book, even if you're not going to you write a patent yourself. It's a really good overview of how the patent office or how the patents work and things like that. So then I filed the patent. It's really, most of the filings are just over the internet. You're basically uploading a PDF document.
Hey, Mike.
Yeah.
I think you said it took you about 6 years to get the final patent. Is that right?
Right.
Okay.
Yeah.
One of the things I want to make sure we cover, because this is wonderful content and incredibly useful for somebody who's potentially developing something they might be wondering whether or not they can get a patent. But I think one of the parts of your story that I enjoy so much is that you didn't just develop a solution, but you had a problem and you developed the solution. Can you just talk? We really just have like another minute. Can you just talk about how you encountered this problem and move from there?
Yeah, well, I mean, I had bought a motorcycle, and I was really just an irritation of you had to clean and lubricate the chain every 300 to 500 miles, and it's not like when you're a kid you could flip your bike over on the handlebars and just squirt some WD-40 on it. You have to inch the bike forward, clean a little bit of chain, inch it forward, clean a little bit. You do until you get all the way around the chain. Then you got to do the same thing with lubricating, or you've got to get the rear wheel off the ground. And my bike weighs like 450 pounds, so it's a little bit of a chore. And having to do it every 300 to 500 miles, it's almost equivalent to having to change your oil. So I just kind of started tinkering around in the garage, and I built several chain oilers before this one, but I kind of had the idea of using wind power. The reason I thought wind would be good is because the wind is there when you need it, and it's not, and when you stop, it's gone. So if it's wind powered, it's also automatic. So that's kind of how the
Yep.
product came to be.
Well, thank you. I appreciate that. I think your story of learning about a problem that you encountered and moving forward to, all the way through learning about patents, this very hands-on approach that you took is fascinating. And like you said, not a lot of people do it. It can be intimidating. So I appreciate that you've provided information on your slides that will help people move into patenting. So that is one way to skin a cat, is to develop your own solution and to move forward with getting your own license. But we're going to move on to someone who has licensed IP from the DoD to build a product that was very commercially viable and that then cashed out. So unfortunately, he is joining us from a distance, and he's not able to use video. So we are going to have a wonderful picture to look at while Somnath Sengupta is talking. So Somnath, can you hear us, and can you join us?
Yes, I can.
Okay,
yes, I can. Okay. So good morning. Thank you for this time to speak with you. The reason I'm on a phone rather than on a video, because as part of my current work, I train adults with autism, and in the background, they're doing their work, doing what they do best, which is create commotion. And so I'm going to have to handle that and talk to you. So, okay. So But anyway, like Kim mentioned, the reason I'm in this call is because I used to work at the Army Research Lab. And not only me, my wife used to work there too. And there was a group of us that invented and created a huge patent portfolio in the U.S. Army Research Lab, all patents belonging to the Secretary of the Army. And the reason we did that is because there was a problem handed to us from our command, at Fort Monmouth, that they wanted a low-cost scanning antenna solution. And in order to accomplish that, a whole family of materials, compositions, and processes were invented, and all of them were patented. So during that patenting process, the Army, of course, helps you with everything, and they bear the cost of full patent and everything. So you sit there and you work with them, you give them the input, but at the end of the day, they kind of carry the weight of it. So technically speaking, you don't bear the cost, you don't learn much about the whole process until you start doing on your own like Mike did. So my first advice would be that if you are in your own business or something, at least try to figure out the process of the patent where they talk about that it has to be unobvious to those skilled in the art. So figure out if you can meet that, and then at the least try to file a provisional patent, which is very convenient nowadays, because that will then teach you the process. So we did all these patents, and then when we left in 1990, late 90s, very late 90s, and we started our own company, essentially, what happened is that we approached the U.S. Army to see if we can license the patent. And what we were told, and any organization will tell you this, nothing different, is that, yes, we believe that you have the most knowledge, so you are the most credible to license it, but you must have a business plan. Or in other words, you must be able to pay for the license. So when we got our first round of venture capital funding in 2000, the first thing we did was to write a business plan and go and apply for a license for the Army for our own patents. We licensed it because, remember, it belonged to the Secretary of the Army, not to us. So we licensed it. We applied for the license. They advertised it at Fed Biz Ops, and then we went through the negotiations and we got the license for it. And as part of the license, you have to pay royalty also. So you negotiate all of those things. So that's another thing we learned. And during the course of the company we had that got acquired by BlackBerry, we built our patent portfolio also. What we did was that, like I mentioned to you, that during the Army days, about 90+% patents were on material formulations and processes. In the company, what we did, we wrote patents on components, subsystems, and systems based on those patents. So if you can imagine, if you ever been to any country and gone to castles to see castles, around the castle, they used to dig a moat to prevent the enemy from coming. Building a patent portfolio is like building a moat. You're trying to protect, your castle, which is your intellectual property. So by having patents, if you can imagine this, by having patents in material composition, material processes, components, subsystems, and systems, you have now built a 5-layer moat to protect whatever you're doing in the company. So that's one thing I would advise all of you, is that make sure that whatever you do, it is in a layered process. And other than that, let's see. But international patents, yes, Mike mentioned that it is expensive. So the PCT is a good way to go. And choose your countries where you want to apply for international patent, depending on where you feel the competition would be. Okay, and Last but not the least, before I end, I must tell you that, the patent is a piece of paper with some intellectual property on it. The best way to protect a patent is to keep continuing to invent so that you can stay ahead of your own patent. And in my current work, what I do in autism or my, my other DoD work, I follow the same rules. I have filed for a full patent in autism, but that doesn't mean I'm sitting tight and not going forward of my own idea, because that's the only way to protect your intellectual property. All right, so thank you very much for your time. If you have any questions, please ask.
So Somnath, when you licensed, you left the Army, supporting the Army,
Yeah.
built your business, and then you went and licensed technology. So you worked with tech transfer offices and the tech transfer professionals to do that.
You follow the regular process like any company. And I will tell you this, because we were Army employees, it is, I can call it a visceral reaction or guttural reaction. We had to probably be more cautious to make sure that the process we follow to license it is totally clean, right? No contact, no nothing, always contacting through our attorneys or the venture capitalists and everything. So you just have to keep it like that.
Yes, yes. So in addition to, while Somnath and his wife were building this company, they went through the same things that every other company goes through. They were both Army researchers, and then they had to learn about how to run a company, how to hire people, how to partner with different companies. And then, they went all the way through exit, so they had to learn how to do that. So there's just, one of the key takeaways that I get from your story, Somnath, and I appreciate you sharing it, is how much learning goes on a constant basis, really, throughout the life of the business.
Yes. So you got to be ready to, don't ever lay your sword down, because it's always a fight. Okay. And the other thing is, you will run into problems, but try to solve it. But one thing I have learned in the process of building the company is that, believe it or not, by the time the company was acquired, the number of people, the core people, when you build a company, you build a core with the first hire, and then you build, the company around that. And people outside the core will leave, more people will come, but the core never changes, right? And the core of the company was hired when we did not have a penny to our name. And we were renting a place in Aberdeen that was like 400 square feet. And we hired people at that time who came from Japan, who came from Australia, who came from Spain. We had just started getting the money from the VCs. So essentially, these people were hired based on the founders' dreams of what it can be. So yes, money is important, but one of the things as a founder you will have a responsibility is to carry that vision, carry that dream, that you can put it in front of them. And if you can hire them based on their dream and vision, even in a 400 square feet place, they will stay with you.
Yes. Thank you, Somnath. I know you've got a lot going on there, and I truly appreciate this. I think we might have to have you back on to talk about how hard it can be to build a company. We oftentimes see the end result, which is, you cashed out the BlackBerry and that's great, but there's an awful lot of hard work that went into that, and a lot of risk for you.
It is a risk. Yes, it is a risk you have to be willing to take. And I will tell you, since Kim mentioned about me and my wife both getting into it, when we quit our jobs, just to give you a referral point, when we quit our jobs in the Army and we left to start the company, we have 8 mouths to feed at home, 4 children, she and I, and my in-laws, and a mortgage to pay. And we did it. Okay. Looking back, it doesn't make sense. But the interesting thing is that when you're doing such things, you don't feel it. Okay.
Yes.
So yeah, you have to take risk. You cannot have your feet on both boats, because you're going to sink.
Yes. Thank you, Somnath. I appreciate
You're welcome. I'm going to drop off.
Okay. Thank you for your time. I appreciate it.
Thank you. Okay.
Have a great day.
Take care, guys. Bye-bye.
Bye. And so I think Somnath's story in particular is a great segue into our next couple of guests who are going to talk about some of the technology that's available through the DoD labs. Just as Somnath did, anybody can license technology. Anybody who's capable and has the capacity to develop that into a product can license technology. So the first person we're going to talk to is Barry Datloff, and Barry is responsible for medical technology transfer for the U.S. Army's Medical Research and Development Command, which their footprint is in Frederick County. So he's going to talk to us about what they focus on, how they partner with businesses, and share some really interesting stories. And I believe a colleague of Barry's is on, Irina, has also joined us, and she has licensed some IP from Barry. So take it away, Barry. Thanks for being here.
Thank you. My name is Barry Datloff, and I envy the inventors like Irina and Mike. Mike, in a way, you're a classic garage inventor. I'm actually a bedroom inventor. I'm addicted to startups. I'm actually a patent filer and entrepreneur as well. And being on both sides are really, really important for people in tech transfer. And the reason is that it's very, very difficult to start a company. I have to admit, it's difficult to work with the bureaucracy. And so our apologies to all. Sometimes it's a lot easier to go out and push your own ideas. But when you combine ideas, there's truly power in the knowledge that comes out of the labs and the collaborators that frequently work in our licensee community. So tech transfer at the U.S. Army's Medical Research and Development Command is headquartered out of Fort Detrick, which is here in Frederick, Maryland. And we have a phrase called assistive technology transfer, which is basically a way in which we help companies get a product to the warfighter, as opposed to many other federal laboratories that don't buy their own products. We do. And so if you look at our ability to actually field products, it has to be a product that helps the warfighter stay safe or actually helps them if they've been injured. And our labs are located worldwide, both here in Maryland, Texas, Natick up in Massachusetts. But we also have research labs in the tropics where many of the diseases that we're most worried about are located. It's a particularly large organization. We're part of the Army's Futures Command and very much aimed at predicting what will be the threats, what are the things that we need to worry about going forward. But the past, as you have seen with pandemics and things of the sort, continue. No surprise to you, vaccines and therapeutics are a major part. Many of you have heard of USAMRIID, Walter Reed, many of our laboratories around the country. But we also do diagnostics, devices, and medical IT. And the devices and the medical IT continue to grow. There's more possible, truly thanks to the miniaturization, both on the chip side as well as a number of materials that enable us to literally put things on our watches, put things on belts. At some point, some of these things will be put in places that we've only imagined, like earrings. So in the old world, patents and CRADAs were really the primary tool of tech transfer. But to stay on the bleeding edge, we have to evolve. And we're now utilizing things like OTAs, software licenses, biological material licenses, partnership intermediary agreements. So we have more tools in the arsenal, but in order to keep our eye on the prize, it's products for the warfighter that we measure our success by. I'd like to tell you a little bit about one of the technologies that we're always looking for additional things that would help the warfighter. The Shrail is an example of a bed rail that attaches to a gurney. And far forward, surgeons don't have enough hands to use to operate if there are only 2 surgeons and 1 patient. The typical chest retractor is not available because where do you put it? On a regular OR bed, there's a railing. So some of our surgeons actually invented this. We filed a patent, licensed it to Morzine. And when you look at, okay, why is that important? It's not potentially just for the warfighter. And so what I'd like to talk about is the possibilities that your startup companies can actually help us out and get us there from here. So if you look at the Shrail, if you could attach a portable respirator to it, you could intubate somebody. Well, Surgicure has just signed a license with us to commercialize a bite block pictured in this slide as a way of putting an intubation tube into a patient so that they don't break their front teeth. Many of our long-term burn intubation patients actually wind up with broken teeth because they gnaw on the tube. Here, the bite block puts the pressure on their molars, and it also provides tiebacks that are further out on the face so that if you do have a burn, you don't wind up with facial scarring. This is an example of an attachment to the Shrail. Your companies may actually have other attachments. You'd be surprised at some of the things that people have suggested. If you've got good ideas, send them our way. We appreciate it. And if you have ideas for the bite block, do send them our way. One of the things Assistive T2 is about is not sequestering or quarantining our ideas, inventors, and our licensees. It's really about crowdsourcing additional solutions that some of us may never have thought of. MRDC, in conjunction with groups like TEDCO, University of Maryland, DefTech, FedTech, and all those other techs like TechLink, we're bridgers. We like to get companies that have been founded and might have some initial federal money to angel venture and eventually the marketplace. And this bridge is a critical multi-party aspect of fielding a product. It's not just license it and be done. And as Irina can attest, I want very much to help our licensees succeed, and it's not about the money. We have technologies that come out of left field. We have your classic lone wolf inventor, like was previously described, but we also have programs of record that we've spent millions, tens of millions of dollars on for decades. Most of our inventions come out of the research lab, but you know the ones I like the most? They're the practitioner inventions. These are inventions that ultimately come out of a need. If any of you ever saw the movie Robots, see a need, fill a need. That's our story, because in a way, the can-do attitude of Army personnel, both civilian, military, and I hope to believe that our contractors are inspired in the same fashion, duty and mission. We get inventions that are completely out there, and we have to figure out, how do we develop it? So when you ask the Army for help in co-developing either your invention with ours or licensing one that was developed by the Army, you've got to contextualize it and fully appreciate who's behind it, who's going to be behind it in the long run and the short run. We have a long list of mechanisms in tech transfer. My apologies for the length of that list, but different laws, different gigs. We maintain a DoD biomedical federal funding list. You're welcome to a copy of that if you drop me an email through Kim or directly through my contact page at the end of this presentation. Because, as is no surprise, patenting requires money. Money requires investors and or non-dilutive capital from the federal government. without that IP, it is hard to raise additional capital. We are moving as a nation, as an army, as an industry in biomed to leverage the software, both through the appification, the SaaSification, the back end, big cloud, data analytics, you name it. And our hope is to make that more accessible to companies. We're sitting on a patient population in the soldiers who are very healthy, but all of their family and their health records give us the ability to do deep dives. And because we're located around the world, some of those dives can be epidemiological surveillance as well. The Maryland biomedical tech transfer ecosystem is complex. For those of you located in state, if you're not on here, other than the companies, obviously, or there's an error, please correct this for me because it's constantly changing. But we are rich, and I mean really rich, in the depth of research that is being funded currently by the federal government, the state entities, and many of the universities. So to summarize, in the vaccine and therapeutic traditional world, we wind up generally working with the larger companies. But that's not to say that a brand new idea and a brand new company can't be licensed. By way of example, we do license companies pre-venture capital. And we sometimes do it even pre-angel capital. And that's because we have a small business preference by law. And face it, we like risk takers. They sort of look like us, you know what I mean? So I'll end at that point. If you have questions, feel free to reach out directly to me. If you can answer all 26 of these without colluding, I will buy you a free lunch.
Thank you, Barry. That was incredibly informative, and it's almost like you are an entrepreneur who has pitched before because your timing was perfect. So I appreciate that.
It's on the screen above your head.
There you go. So one of the things that you mentioned, you had a slide that talked a lot. There were a lot of acronyms. You talked about OTAs. We talk about PLAs. We talk about CRADAs. And I'm just going to plug at this point that we are going to be having another one of these online meetups, if you will, to discuss some of those tools that are available for businesses. And that will be coming up in a couple of weeks. We'll put that up on our meetup page. So thank you, Barry, again, for sharing what's going on at MRDC and how you enjoy working with businesses, because that's important. So next up, we are going to talk to Matt Jones. So Matt is a technology transfer specialist for the Army's Chemical Biological Center at Aberdeen Proving Ground, which is in Harford County. And we've been working with Matt quite a bit. When I say we, I mean DefTech, partnering very closely with him, especially in this pandemic period, I guess, to help get some technologies out. But Matt is going to talk a little bit about his work that he's doing there, and some of the technology that's available for license, and some of the ways that he works with business. So Matt, I am getting ready to pull your slides up. Not right now. I want to make sure I have the right batch up. And we are ready for you. Are you there? Are you unmuted?
I'm here, and thank you, Kim.
Very good. Thank you.
Yep. And I appreciate following Barry, who's pretty much one of the godfathers of tech transfer. So it makes my life a little easier. I can concentrate more just on my command, I guess. So yes. On the first slide here, so I'm from CBC, that's Combat Capabilities Development Command, Chemical Biological Center. We're also part of Futures Command. A good way to separate us and Barry is Barry concentrates, Barry being medical, and we're kind of non-medical. So we're going to go into that a little further, but that's a good starting point. Is we're more non-medical as far as chemical biological defense. Slide 2 gives
I'm sorry, Matt, give me 1 second. Apparently, I was not sharing your slides. I thought I was sharing your slides, but just so everyone knows, this will explain the acronyms. We're going to be heavy acronym. We can't help it. I have 40 years with the DoD. I'm used to it, but there we go. That's the CCDC and CBC, and we're on the second slide now, Matt. Sorry about that.
That's fine. Thanks, Kim. So that's us. We're in 4 locations mainly, almost 1,100 federal civilians, plus for a total of about 1,400. We have a lot of very valuable contract employees also. Rock Island, Illinois, Pine Bluff, Arkansas, Dugway Proving Ground, Utah, and headquarters in the Edgewood area of APG. If you've never been to APG, it's a nice place, so maybe come out and see us. Very unique infrastructure. So over 1 million square feet of lab and chamber space, including biosafety level 2 and 3 labs that can handle just about anything. If you know anything about biosafety level labs, we do explosives, toxics, everything. We have the majority of the nation's chemical surety hoods for dealing with chemical agents. So that's part of us. Now remember, don't lose sight, we're not just a lab organization. My background is environmental science, mainly in the field, so we'll talk about that a little more. Novel approaches to suburban defense, definitely us. Emerging suburban defense, that's just some of the ways right there. You're looking at synthetic bio, cellular toxicology, threat agent science. Now that's all lab stuff, which is our base and our beginning. But remember, that's all non-medical. And then moving on to our core capabilities, which include testing, sample analysis, which is including agent handling and surety. So that's moving outside the lab a little bit more too, for the agent handling and surety. Chem biosystems engineering. Like Barry was talking about, we have algorithms that we can license. We have IP that is purely code, computer code. And then operations. And one famous example of a Chem Bio Center operations was back in 2014. If you remember the Syrian chemical stockpile that was put on a ship and taken out into the Mediterranean, all the operators on that ship, it was a Navy reserve crew crewing the ship. All the chemical demill operators were from the Chemical Biological Center. So they were, the center was very proud of them. It was a long operation. They were at sea for a long time. Moving on, next slide. More core competencies, experimentation, safety. Very much everything is safety driven with us. So we're renowned for our safety program, our risk management, threat agent science, basic research, modeling and simulation, which everyone knows modeling and simulation saves funds. It doesn't replace testing, but it augments it. And then prototype development all the way up through manufacturing. Now, not manufacturing to sell, but prototype development. We have a robust advanced design and manufacturing capability for prototype development. More core capabilities, testing, and that includes testing of clothing, permeation, masks, all the way through. We also do one of the side businesses that's not always known is smoke and obscurance, is an Army mission that is at the Chem Bio Center. Sample analysis, agent handling and surety, and then operations and systems engineering. Now, as Barry discussed, solutions require collaboration. We love small business. One of our favorites, really. We work with a lot of startups, as Barry said, people pre-venture capital, people on their own dime. You know, we don't care. If you have a good business plan, bring it to us and we can work together. Academia, we work with everybody from MIT to Georgia Tech to you name the university or college. DoD and federal partners, local governments, police departments, state police, and then international. We have a very robust international office. We do a lot of treaty compliance stuff. You see all, again, like Barry discussed, you see all the types of agreements. I'm not going to go over all of them. We have all of them. And as Kim said, we're quite busy with the world as it is right now. It's unfortunate, but we're uniquely positioned to assist the country. So we're fortunate, and there are a lot of smart people where I work. I don't kid myself because I know a lot of the really smart guys and women, and they're really an asset to our country. So there's our contact information. Public Affairs is Rick Arn, and my supervisor, Amanda Hess. You can contact her. You can contact me through Kim if you need to. She can get you my contact information. And then I think that'll about do it. I didn't want to belabor too long. We can be your one-stop shop for non-medical chem bio protection and operations, also smoke and obscurance. So
thank you, Matt. I think that was incredibly informative. Just to let people know all the various things you do, that it's not that your technology and the work you do isn't just beneficial to the Army, it's beneficial to society in general. So one of the things, if you have a few more minutes, if you could talk about some of the technology. So we have a picture here of a man holding an unmanned aircraft system. Can you talk about some of the technology that's available for license?
Absolutely. So are we going to start there with the UAS picture?
Yes.
Okay. That's a picture, you can tell by the geography, that's Dugway Proving Ground. That is one of our former technical directors, Dr. Corvo, holding a quadcopter, which was actually, to start with the quadcopter, it was actually constructed through our by our advanced design and manufacturing. I think mainly 3/4 of that was actually 3D printed on site at Edgewood. Some of the parts were purchased commercially. And then if you look at the quadcopter beneath it, you'll see that little white, they call it the puck. It's called the puck. And what's unique about that is it contains sensors. It can be chemical agent sensors, biological agent sensors. We have intellectual property that it has counter UAS sensors. So it's very relevant to today's environment. The center is very, very proud of that. As you can see, it's the director holding it. So that's just one of our, we have all kinds of work. And what's unique about that puck is it doesn't have to go on to just a UAV. It can go on to a ground vehicle. It could go on a seaborne vehicle with if it had a little more, robust refining. It's available for any kind of continued research and development. So that obviously gets a lot of interest for us.
Yes, yes. So the next is the masks, the photo of the Army wearing masks.
Yep. Okay. And so you see there, what you see there is it's a couple years old. It's two soldiers. What they're wearing around their face is called the acronym is IREPS, IREPS, which is Integrated Respiratory Protective System. What that mask is it's NIOSH certified to protect against tear gas. So if they're wearing that and say they're doing civil duties, they could wear that in a riot where there's being tear gas is being employed, and they could be able to breathe. So unfortunately, that's as far as the development got on that, but it too gets a lot of attention for really the possibilities. Mm-hmm. And so it hasn't been licensed yet. It's had a lot of interest, but it's certainly available. And those are just two small technologies. Like I said, we don't have time to talk about everything. We have algorithms. We have a lot of detection science stuff, physical stuff that is quite groundbreaking. So, contact us and we'll certainly talk.
Yes, thank you. So that That is, I think, eye-opening for everyone to understand that the work that goes on in the DoD lab and I was going to say the state of Maryland, but all across the world, actually, that technology that they're developing is available for license, and the big brains that Matt was talking about are available for you to access to build your products and services. And that, thank you so much, Matt. I really do appreciate you coming on this morning and talking about all of that.
Sure. I mean, I've enjoyed it, Kim, and I'll stay on if there's any questions or anything. You know, feel free to talk to me.
Okay. Okay. Thank you. So this is a great segue again to talking about what DefTech does, and we're not going to take up a whole lot of time talking about that, but the point of this celebration today is to talk about innovation and invention and helping businesses grow, which is what DefTech is all about, and especially helping businesses connect with this technology and the resources that are available in the DoD labs in the state. So we're fortunate in our state that this is a program, like I said, of the Maryland Department of Commerce, and we're fortunate that the Department of Commerce recognized that there was a gap, that the businesses in the state weren't necessarily accessing the technologies in the labs. So before I say everything there is to say about DefTech, because I am a little bit in love with the program, I'm going to introduce you now to Dr. Gary Evans, who is kind of one of the innovators that got this whole thing off the ground. Morning, Gary.
Good morning. Can you hear me?
I can hear you. And can you tell us a little more about DefTech and why we're so awesome and how we help businesses grow?
Sure. So just to go back to what you were saying, DefTech is an initiative of the Maryland Department of Commerce, and it is funded in part by the Federal Economic Development Administration, but it's also supported by 13 partner organizations that we have around the state who contribute funds and in-kind support to the program, and we are hugely appreciative of the support that they give us. Very briefly, as Kim said, the purpose behind DefTech is to try and help Maryland-based companies access the resources that are available in the DoD research labs in Maryland. And that could mean patents. We've heard quite a bit about people licensing patents in one form or another. But it can also mean a lot of other arrangements, which some of the speakers touched on, including cooperative R&D agreements and other forms of contract that allow companies to engage with the labs and make use of the facilities and the equipment and the expertise that's available through them. There are a vast number of highly qualified technical specialists within the various DoD labs in Maryland, tens of thousands of them literally, and their expertise spans an unbelievably wide range of technical areas, and so they're a phenomenal resource to call on. So we do three things. The first thing we do is try to raise awareness that these resources are there, because most people don't realize that they are. And so we conduct events like this, we go out and we meet with people one-on-one, we speak at other people's events, just to get the word out that these resources are available and raise people's awareness. The second thing we do is to provide, as much as we can, some educational content. We don't have the resources to run full educational programs, but with events like this, we try to convey some useful information, give people some background, and make contact with them so that if people are interested, if you're interested, you can contact us and learn more, both about what the resources are that are available from the labs and how you can actually access them. And Griffin, who's on the line, does a phenomenal job of searching the available patents from the Maryland DoD labs and helping companies explore if there are any existing patents that may be relevant to their business. And the final thing that we do is we facilitate the process of helping companies engage with the labs. As you will have heard, the tech transfer folks in the labs are extremely knowledgeable, extremely approachable and very good at what they do. But by way of in part the fact that it's part of the Department of Defense, people don't necessarily feel that they might be accessible, or they may feel that there's a lot of administrative hurdles that they have to get over to be able to establish a relationship. And we just help with that process. Mostly, actually, those things aren't really true, but in any case, we help people find the right lab, find the right scientists, work with the tech transfer offices, and try to arrive at a way forward which is of value to both the military and the company. So that is, in a nutshell, what we do. At the moment, our focus is primarily on the 3 labs at Aberdeen Proving Ground, which, as we've heard, are CBC, the Army Research Lab, and what used to be the Communications and Electronics Group and is now called C5ISR. And at Fort Detrick, Barry's Group, MRDC, and at Fort Meade, the NSA as well. And so that's our footprint. But in actual fact, we will help anybody find and engage with any of the DoD research labs within the state if that's the right place for them to go to. So there you go, Kim. I think that was probably about 3-5 minutes. So that's the 30,000 foot view of things. That
was great. Thank you. So one of the things that I will just share with everyone is that we do have, I'm starting to lose count, but right around 50 client businesses that we have supported with DefTech. And we've done 2 surveys of them just to ask 4 short questions, ask about how we're doing, if they found the time with us useful. And overwhelmingly, we get a really good response to that. So one of the things that business owners or the technical people in their organizations appreciate is that DefTech will go out and learn about their company, learn about what their current challenges are, and then sort through nearly 2,000 patents that are available in the DoD labs here in the state of Maryland. And as Gary mentioned, we have had companies outside the state that have asked for our support, and we've done that if they're licensing something from one of our Maryland labs, because this is a Maryland program. But that is just for us to take the time to do that. Larger companies sometimes have their own internal people that are looking at patents on a regular basis. And because, it's challenging to keep up with who's doing what, we do that on behalf of companies. So the feedback we've gotten is that that's a massive time saver for them. And then just walking them through the very messy and sometimes complex process of getting to the point where they're licensing something. So just a couple things too to wrap up is that I think Gary mentioned some of the companies don't actually want to license technology. That may be the entry into working with the federal lab, finding out what they've got available or learning about their equipment that's available for use, or the scientists that they could work with, and they enter into different agreements. So that is, I think that's pretty much everything in a nutshell. I know we went through an awful lot. I also want to just mention that there are several different types of businesses on with us today, and there are several different inventors that are on with us today. Sue Carr has invented, she is also very much, as Mike Steele, our first presenter, saw a problem. So she was working as a pharmacist. She recognized a very specific problem and was frustrated that there wasn't a solution. So she built a solution, and it's called the FROG, which I don't remember the entire acronym, but it's a filter needle, and it saves hospitals time and money. It reduces needle sticks, which are very, very costly. And although I haven't asked Sue yet, I'd like her to be on a future opportunity, future meetup, to talk to us about some of the work that she does. So I am watching the question, filter removal of glass. Yes, and he agreed to be online since I've asked publicly. Nothing like coercing. So I think that we are going to say just thank you so much, everyone, for joining us. It was fun putting together very, very quickly a event to celebrate innovation and invention, which is something, of course, that's near and dear to our hearts. I'm going to quickly share our contact information, which I haven't done in the past, but I want to be sure everyone can get in touch with us. As we mentioned, I think Gary mentioned in the chat that if you would like to receive a copy of the slides, because of some restrictions with MeetUp, I can't just attach the slides to a message that I might send you from our MeetUp site. Just shoot me an email, and my email is kim.mozingo@deftechmd.com. And there's our information. And I'm going to thank you again, everyone, for joining us. Please have a wonderful day. Wash your hands, stay inside, wear your masks, be careful, and stay safe and healthy until we see you in next week. For our topic is funding product development with SBIR and SBTTR funds. And if you don't know what those are, you're going to definitely want to join us. So thank you again. Have a great day.